Okay, let's talk about homework 2. I'm really excited about this homework. So this homework, and it's my goal that each of the homeworks we have for this course reflects a unit. So the prior homework was on Unit 1, and it really focused on code management. And so this homework will be based off of Unit 2 with data management. And so I've titled this homework Maker's Toolkit, and it's designed to be a command line interface application. So the assignment goal, you break the assignment goal into 4 parts. The first part is that you will have to select an API. And so you're going to select an API from homework 1 developed by some other student. And so I'm going to include a link that's going to have everyone's submitted API available, so you can go through and select the one that you want to use for this assignment. So I suggest that you peruse all the submissions, and I definitely encourage you to choose an API that, first of all, inspires you, but second of all, that you think would be easy to use. And so how can you decide if it's going to be easy to use? You can use the Javadoc documentation to be able to see all of the classes and interfaces and methods that are available to you inside of their package, inside of their API, to be able to learn what functions you can call, what instances you can make. And you can also look at the JUnit code that's submitted to see demo examples of the code in actual use. And so if it's a good test fixture, if there's a good test plan with the JUnit code, you should be able to see how all the methods and all the classes are effectively called, so you can build an application around it. So when you select an API, you have to make sure that you include the original author's name in your project files, because they will receive bonus credit for you using their API. Now, also note, to those of you whose API is selected, you do have to provide any kind of support to method calls that might break their contract via the API documentation. So if someone's attempting to use your API and they're trying to go ahead and follow your JavaDoc specs and instantiate an instance of an object and it doesn't work, you have to try to work with them to find out and identify why that code isn't working. Okay, the second assignment goal is, once you've selected an API, you're going to design a Maker's Toolkit app. So you're going to design and structure an app that allows a user to make and store new custom instances of objects built using the selected API as a command line tool. So a command line tool is one that you can use from the console. Depending on the function of the API, the user may create like item inventories or monster bestiaries or player options or spell books or shop systems or map makers, or like the idea for this first time that I've run this, I think I've kind of targeted at making an item-based system, but I'm definitely going to expand this. I've rewritten it, I've reauthored it so that the RPG subsystem that each person makes could be anything. It could be for customizing monsters or spells or player classes or things like that. So whatever API you select to do, you have to make effectively an app that allows you to make content, game content, that makes specific concrete instances of those things that the app is designed to make. And so you should design your app to have at least 3 core packages. You should have a model package where all of your app logic goes. You should have a view package where all of your output logic goes. That's all of the things that get displayed to the command line. So you shouldn't have any system.outs inside of your model package. That should only be inside the view package. And then your controls, being able to prompt the user and get input from the user, should go into some controller package. And this allows you to separate your responsibilities of everything that your app does versus all of the data your app displays out to the end user versus all of the data that comes into your end user. And so use classes to group similar methods and use packages to group together similar classes. So I do want to see appropriate organization of your applications for this assignment. And it would be useful if you also used a UML or Unified Modeling Language to scaffold your app before you implement. I'm not going to require that. I'm just saying that that would be a useful tool for you to look into to start designing the interactions of your app before you start implementing. So the third goal is going to be to actually implement your Makers toolkit. And by Makers, you can think of this as a dev toolkit. You are like a game developer who's using the API to create game content that will then be loaded into the game and be used as the collection of monsters or the collection of actual items. So this toolkit must use multiple collections. So the actual toolkit, when you go to launch this, should use multiple collections from the collections framework. That we spent a long time. We spent more than 2 full weeks, so like 4 lecture weeks, talking about the collections framework. So I want you to use that to manage the user-generated content. Then, so the user is inputting, like they're building, you're going to offer a prompt that allows them to build items or whatever from the command line. Then you're going to store that created item into your application. So you must include at least one instance of a list, of a set, and a map. So I'm requiring you to use one of each of the core collection types, container types that we talked about. And the operations your toolkit should be able to support is sorting or filtering or searching or accessing or adding or removing from your creation system. So like if I add a sword, I want to be able to see that I made that sword, or I want to be able to filter swords from axes, from spears, or I want to be able to search. If I gave that sword a name, let's say it was Ted's sword, I want to be able to search and find that sword. Or if I want to filter all weapons that have an attack power of 10 or greater, I want to be able to do that. So think of the different operations that allows a designer who's developing all of the items in a game to easily be able to filter those items or sort those items maybe by level, to be able to access individual items or groups of items, be able to remove items or add items into the system, into the inventory system. And finally, I want to make sure that you can test your Makers Toolkit app. So test your Java app, ensure that it executes and operates based on your directions, create a Readme.md file that defines the operations of your toolkit. And so note, this toolkit may be used as the basis of a future homework project, but it's not intended to be a game in and of itself. Hint, hint, right now, as you create content, after you're done using your application, it'll all get destroyed. You can guess that the unit 3 with all the input output streams that we're going to be doing is to be able to save the content that gets generated and reload it when you reload the app. I'm just giving you a hint. That's where we're going to go with this. Okay, so some learning objectives. I want you to learn how to use external code designed and developed by someone else who is not you, and use that to build out your own full application that operates at the command line. It's essentially a command line tool. It's a command line Java application that allows users to make game objects such as items or spells or monsters or skills or whatever the selected API allows for you to do. And so these the user made objects should be added and managed using the collections framework. And you must use at least one of each collection type, a list, a set, and a map. So these are the learning objectives. I want to make sure that you know how to use another student's API, that you can be a client to an API system that wasn't designed by yourself, and that you learn how to use a list from collections, a set from collections, and a map from collections, and that you learn how to separate your code into an intelligible way. So I prefer a model view controller, and that's a very common way of subdividing an application's code base. So just some quick implementation advice: focus on building an application that builds, searches, and sorts items from the selected API. Start with something simple, a simple tool where maybe you just add something and then you can look at it and maybe delete it, and then constantly add complexity to it. So that's what I call a top-down iterative strategy to software design. You start with something basic, give yourself a simple goal, and then give yourself a new goal that adds a feature on top of that, and then a feature on top of that until you have your completed application. I also recommend that you use a test-driven development strategy. And if you do test-driven development, that allows you to use JUnit. So if you do opt to do that, you can design a test plan for your maker toolkit, and then you can create a test fixture, and each class can have a test case, and you can test that out before having to like build out your full application. So this allows you to kind of test individual classes at a time. You can use that strategy not just for API development like you did before, where you don't have a main method, but you can even do that for applications that do have main methods. So I do encourage you do take a test-driven development approach. It's the preferred approach for software engineers. And also, I'd want you to make a readme.md file. MD stands for Markdown. You should make TXT files. GitHub, GitLab, they automatically parse MD files, Markdown files, and display them into the root directory that your repo is at. You should also always make JavaDoc comments inside of your source code as well, even if it's not truly an API, because the idea is that the README is directions that's designed for the end users, the people who are actually going to use your app. But the JavaDocs are there as API instructions for any app developers who want to come and extend the functionality in future revisions. So just because this is the state of your app right now, doesn't mean that's going to be the eternal state. So it's always important to produce that JavaDoc specification so people can easily see all of the methods as they're defined and how they interact and how they can potentially expand your application to do new and cool things. So again, you're welcome to use any lecture code or lab code. I'm going to update the GitHub repo so everyone has access to that. I'm also going to share when I go to share this document, I'll give you links on where everyone's API is at. And I just gave some basic showcase examples, not necessarily the inventory system, but of how like randomly generated items or how specified items might look. So I think I just found some randomly generated or some like character creation things just to give you insight. And so the importance of why I think this is an important app outside of it just being an academic project is that it's probably allows you to create your first custom developer toolkit. So designing command line interface developer tools is a valuable mini project that represents a completed application in and of itself. And so once you learn how to create these like command line tools, I mean, clearly you can then build off of that to make these bigger GUI based tools, but command line tools are very powerful for developers because you can create tasks that you just go ahead and implement and execute from the command line and then hand this off to a team member who can start creating content while the game is still being made. Also, it's a portfolio project. Employers and recruiters commonly prefer candidates who have project portfolios to demonstrate their technical capabilities. So this gives you another opportunity to convert or treat a homework as a personal project that you can share with prospective employers. I give basic inspirations on what you might make maker kits for. But again, the idea is that it's used for crafting the game content that will then be loaded into a game. I give the basic rubric, but the rubric is kind of indifferent to me because it gives you an idea of what I'll be looking at, but we'll do the audits anyway. So you don't really have to mind too much about the grading rubric. And then submission is very similar to how we have been submitted before. Publish onto your Git repo. In fact, every project that you publish onto GitLab should be its own repo, honestly. I would actually recommend everyone make a GitHub account and they publish each project onto GitHub, but also zip up your files and submit them on Moodle so that I can actually assign a grade to them. And that's it. That's the write-up that I have for the second homework. I'm really excited to see how homework 1 can kind of segue into homework 2 and how homework 2 will eventually segue into homework 3. And hopefully, if we can get through unit 4, you can imagine what we're going to do with all this by the end of it, where we get everyone's serialized data. I just make it all public And I hope that you can potentially make some graphic user interface game by the end of the semester with some of this content we create. So does anyone have any questions? About the instructions on this homework? And again, if you do, just go ahead and ask on Discord. But I'm glad that we kind of took the time to talk about this today. That way you can even use this weekend that's coming up to start working on it, and you'll have my deep explanation of it posted onto YouTube. When is homework 2 due? So likely, because we don't have much time left, I'll make it due. Let's see, not next Monday, but the Monday after. That'll give you 2 weekends to work on it. Excellent. Is there any other questions? And hopefully that'll still give us another time to have a third homework. And then I'll likely try to pin up a fourth homework, and depending on how time is, might make it a bonus, or we'll see. We'll play everything by ear. Excellent. Well, if there's no other questions, I will go ahead and end today's lecture here. Everyone, have a great day.